Okay, let's see question C, which solve the initial condition problem using the Laplace transforms method. So question C, we have y2 prime minus 6y prime plus 5y equal to 29 cosine 2t, and initial condition y of 0 equal to 3.2 and y prime of 0 equal to 6.2. Right, so to solve this problem, let's assume that we are going to pass the variable y into our Laplace transform operator, and then we get y of x, right? So to solve this differentiation equation using the Laplace transform, we are going to pass every terms of this differentiation equation in a Laplace transform operator. So we are going to pass the y primes, and then we are going to pass the variable y into the Laplace transform operator, and also we are going to passing the Laplace transform operator, okay, with the cosine to t, right? So we're going to solve the Laplace transform for each of these terms. So Laplace transform of the second derivative is equal to the x squared y of x minus xy of 0, which is initial condition, then minus y prime of 0, right? There is the Laplace transform of the second order derivative. And then for the Laplace transforms of the first derivative, this is equivalent to x y of x minus initial condition y of 0, okay? And then we have plus the Laplace transform of y, right? Laplace transform of y is equal to y of x. And then on the right hand side, we are equal to the Laplace transform of this cosine 2t is equal to the x divided by x squared plus 2 squared, which is equal to 4, right? This is the right hand side. Now we see for the left hand side of the Laplace transform, we are going to substitute the initial condition and we solve this. So we're going to substitute our initial condition that we have. Okay, initial condition that we have. So here we have the y of 0, which is equal to 3.2. So here we have a 3.2x, and minus y prime is 6.2. Here is 6.2. So in this case we have minus 6. Okay, xy of x. So this is still is x, y of x, minus the initial condition y of 0, which is 3.2, and plus 5y of x, and this is equal to the right hand side, right? The right hand side of the functions. Okay, right. So now we are going to simplify this. We want to put the y of x in on the left hand side. Okay, we are going to accumulate the points here, where we are going to accumulate the y of x on the left hand side. So this y of x is equal to x squared minus 6x plus 5. Then this should be equal to 29 of x divided by x squared plus 4. Right, so we are going to accumulate that. We can see over here, we can put the y of x on the left hand side, right? We can put this y of x on the left hand side over here. Then here we have shift this we still have a 3.2x minus 13 over here. We have a 3.2x over here, 3.2x over here, right? Okay, now what do we have? We need to divide the right hand side we're going to divide this right hand side, okay, this right hand side over here with this one, so that we can get the y of x on the left hand side only. Now we see if we divide this y of x on the left hand side, and now what would we have? We have 3.2x minus 13, then divide by x squared minus 6x plus 5, right? And then what we have? We have 29x, then divide by x squared plus 4, and then we x squared minus 6x plus 5, right? Okay. Now, to solve this, we need to use the fraction decomposition method for each of the terms in this y of x. Use fractions decompositions method. Okay, use the fraction decomposition method. So we rewrite this. We are going to solve for this term first, right? So we have the 3.2x minus 13, then divide by x squared minus 6x plus 15. Okay, so we can factor out the denominator, 3.2x minus 13. So we factor out the denominator, we have x minus 1, x minus 5, right? Now we need to separate this into two terms, so we use a fraction decomposition. That means a divided by x minus 1 plus b equal to x minus 5. Okay, we're going to solve for this to find out what is the a and b. Now we solve for a and b, right? Solve for a and b. Solve for a and b. So what we can do is we compare the coefficient. That means a times x minus 5 plus b x minus 1 must be equal to the numerator of this 3.2x minus 13, right? 3.2x minus 13. Now if we let s equal to 5, if let s equal to 5, that means this one will be equal to 0. Then we only have one coefficient value of v, right? Then we can find what is the v value. What is the v value, right? So the v value here, we substitute s equal to 5, and v value is equal to 3 divided by 4, right? So the second coefficient value a, or variable a, that can be let the x equal to 1. If we let a equal to 1, then we can eliminate the variable v over here. This term will be equal to 0, right? Equal to 0, then we can find what is a value. What is a value? That is 2.45. Yes, 2.45. Now we already solved for the first term, which is this one over here. For this, okay, we solve for this. So the next, we're going to solve what is this composition. Okay, use the fraction decompositions for this to find the Laplace transform. Okay, to find the Laplace transform. Okay, so